This is a video for day 9. This is the introduction to logarithms. Here's a whole bunch of stuff we should already know. That anything to the power of 0 is 1. If you have a term with a negative exponent, you have to move that term to the other side of the fraction and then change the exponent positive. When multiplying numbers or variables that have the same base, you add their exponents. If a number or variable and its exponent are all being raised to another exponent, that's power to a power, you must multiply the exponents. When dividing numbers variables that have the same base, you subtract their exponents. But again, remember, we just eliminated the ones that the top and bottom of the fraction had in common. Okay. It's helpful to have the power sheet, because for logarithms you're going to need to know the relationship between a base, its exponents, and the answer, because a logarithm is just a different representation of that. So make sure you have a sheet like this. Okay. So we're going to write exponent expressions in logarithmic form. There's no actual math going on here. We're just writing it, the relationship of the three numbers that form an exponent relationship. We're rewriting it in logarithmic form. So as you can see, you can just look at the graphic right here. You know, your base is just some number, or it could be anything, and then your exponent's the little guy up there, and it equals something when you raise a number to a power. A logarithm just reassembles it and like makes it look a different way, but it's the same three-number relationship. So for instance, if you know that 3 squared is 9, you could write that in logarithmic form, and the base is 3. So you write log base 3. It kind of hangs a little lower. It's a subscript, where an exponent is like a little higher, like a superscript, it's called. So if you write this relationship, you write log base 3 of 9, because that's what this relationship is equal to. So log base 3 of 9, and then is equal to the exponent. And in this case, it's x in the example, but in our case, it's 2. So again, this states log base 3 of 9 equals 2. Whereas in exponential form, it's saying 3 to the power of 2 is 9. All right, so here's a whole bunch of examples. We're just going to write them back and forth. So if it's in exponent form, like this one and this one, this one, we'll write it in log form. And if it's in log form, like this one and this one and this one, we'll write it in exponent form. So one way you can do it is if your answer is always on the right, or if your exponent expression is always on the left, you just write the word log and then take the base and then pick up the answer and then write the exponent. So log base 5 of 125 is 3. In a logarithm, what it's equal to is always an exponent. So in the same thing, the next one, you just write log base 2 of 32, and it's equal to the exponent, or whoosh, just go back that way. And you can write it backwards. So if you start with the log, it's just base raised to exponent equals answer. So 2 to the 4th is 16. Basically, the smaller number changes size between the two forms. So like in an exponent form, the base is larger and the exponent's smaller up there. And in logarithm, your base is smaller and your exponent's larger right there. So here's the example we did from the last one. Log base 3 of 9 is equal to 2. That's just saying 3 to the power of 2 is 9. And here's some worse examples where everything looks a little bit messy, but it's all the same process. And we're not doing any math. We're just writing these relationships. So 6 to the negative 2 power is 1/36. You would just write log base 6 of 1 over 36 is negative 2. And it's the same thing if you're writing back in exponents. Just grab the base, hit the exponent, and that's what it's equal to. So it's always like making that, almost that, a backwards Nike swoosh symbol. So like 1/4, and it's good to write in parentheses. 1/4 to the second power is 1/16. This guy, whoosh. Log base 1/7 of 1 over 49 is 2. Okay, this guy. You should pause it and try them. I'll pause it and just write the answer. Alright, did you pause it? Good. And that's what your answers would be. And these are a few problems from the assignment. So I'm only going to do a few of these because, I mean, that's your job. So it's just saying if it's an exponent form, write it in log form. So this one is just an exponent form. You write the word log and whoosh. Log base 3 of 81 is 4. Skipping it. This one. Sometimes it gets confusing because you have fractions as exponents. And remember this, you could think of it as, remember the 1/3 power? It's the denominator says the index of the radical. So the third root of 8 to the first is 2. You could think of it that way too. This is just a different type of showing the relationship. So anyway, we know that the exponent's 1/3. We know the base is 8, and the exponent's 1/3. Your answer is 2. So you'd saying log base 8 of 2 is 1/3. Remember, in logarithms, the answer is always the exponent. Alright, how about this crazy guy? This is log base 10 of 10,000 is 6. So let's grab the base, pick up the other number, and then the last number. So this is 10 to the 6th power is 1,000. Number 22. So the base is there, log base 2/3, so 2/3 is the base. To the 3rd power is 8/27. So this is just an introduction to logs, and it's just rewriting, and we're not calculating anything, we're just changing the way it's written from exponent form to log form. So good job, I know you're a pro now. Nice job.